Part F, even and odd functions. Describing functions as even or odd is a way to discuss their symmetry. An even function is a function that's symmetric about the y-axis. An even function is a function that's symmetric about the y-axis. For example, if I have something that looks like this, that function looks even. If I have the point x, comma f of x on my function, I also have to have the same point on the other side of the y-axis that would match up with it, that looks like negative x, comma f of x. One definition we can use of an even function is a function is even if f of negative x just equals f of x. If you plug negative x into your function, you get the same y value that you would get if you just plugged x into your function. Next, an odd function is a function that's symmetric about the origin. An odd function might look something like this. Symmetric about the origin refers to rotational symmetry. If I was to take the graph and rotate it 180 degrees about the origin, then this piece would match up with that piece. If I have the point x, comma f of x on my function, its corresponding point over here would be negative x, comma negative f of x. My algebraic definition of a function being odd is f of negative x would equal negative f of x. If you plug negative x into your function, it will equal the negative of the y value you get when you plug regular x into your function. I can use these two algebraic definitions to test algebraically if some function you're given is even or odd. All we need to do to determine if something is even or odd is find f of negative x. To determine if a function is even or odd, all we need to do is take our function and plug negative x into it. If when we simplify f of negative x, we get our original f of x function, then we say the function is even. If we get the original f of x function, then the function is even. If when we simplify we get the negative of our original function, if we get negative f of x, the function is odd. And there are many functions that are neither even nor odd. We might plug negative x in and not get the original, but not get the negative of the original. So otherwise, our function is neither even nor odd. So to look at a few examples of this, let's determine algebraically if the function f of x equals x to the third minus x is even, odd, or neither. Well, we need to plug negative x into our function, and when you do this, make sure you're showing all the algebra. Make sure you're showing how things actually do simplify back to the original function, or to the negative of the original function, or some other version which would make it neither. I'm going to first write it like this. To do negative x in parentheses cubed, well, negative x is like negative 1x. Cube the negative 1, you get negative 1. Cube the x, you get x cubed. Minus negative x, that's just like saying plus x. This looks exactly like the negative of my original function. This just looks like negative f of x. That makes that original function odd. Next, let's take a look at the function f of x equals x to the fourth plus x minus 2. Again, I want to find f of negative x, which gives me in parentheses negative x to the fourth plus negative x minus 2. Negative x in parentheses to the fourth is x to the fourth. Negative x is just negative x minus 2. This is not exactly the same as the original function, but it's also not the negative version of my original function. This one is neither even nor odd, so I just have to label it as neither.